one, go.
So good afternoon to one and all present over here. Myself Jessica Casey along with
Arjun Sharma and Ansu Paul.
to describe on the topic statistics. So without any delay, I would like to get into the topic. So you all probably have heard about mean, median, and mode. They all are used to calculate the average. Average is a single digit that helps us to know the characteristics of the whole data. And the measure of the central value is called measure of center tendency. So let me break down some formulas so it will be easy to tackle the questions. So mean, first of all, individual series. Direct, we have summation x by n. Here, the summation x means the sum of the numbers and n is the total number of digits in it. And the shortcut method is a plus summation d by n. Here a is the assumed mean and this d is calculated as. So I'll talk about it in the direct and continuous. So this one is for individual series. Moving on to the direct and continuous. We have direct method that is summation f of x by n. Shortcut method that is a plus summation f of d by n into n. Here we have the assume mean. We need to assume a mean because we are not given a mean. So let's assume 15 as a mean. Then we have to find the d like this. Just minus the number from this one. And like that, when you get all the number of d, then you can add up to that and then just put it into the formula and solve it. Now last we have step derivation method, that is a plus summation f of d dash by n into h. Here this n is the common factor and d dash can be measured like this. Here the value that we have just taken out from this one, we just need to divide it by the h, that is the common factor, and here it is 10 because the difference is 10. Going on to the combined mean, we have the formula. So here this x1 and x2 are two different mean, and this formula right here is important to us from exam point of view, and not to mention the time limit is very tight, so just refer to the example in the book, it's already given in the book. Now moving on to the mean, median, we have for individual series that is n plus 1 by 2. For discrete series we have n plus 1 by 2. And not to mention the one that we use the most, that is for group data, that is L plus n by 2 minus CF by F into I. So suppose this one is our median right here, then we just have to take the L30 because it is the lowest, and n by 2 just divided by 2, and the CF, the part where everyone gets confused a lot, the CF we need to take that of the upper one and frequency the same. So I is the difference, that is 10. So now let's move on to the mode. So mode is the highest value, frequency value, and its formula is so here. Let's suppose this is our mode. Then this one will be our F0. Then if this one will be F1 and this one will be F2 respectively. And the I is 10 obviously because the difference is 10. Now talking about their relation with each other. If it is symmetrical, then we have mean equals to median equals to mode. And if asymmetrical, then mode equals to 3 median minus 2 mean. And like that, let's talk about dispersion. Dispersion is the measure of variation of the central value, and we can calculate it by calculating range, quartile deviation, standard deviation, and mean deviation. So range, I guess you all know about range. It is the largest value minus the smallest value. Its coefficient can be calculated by this formula right here. And quartile deviation, where it is Q1 equals to So this one is for the Q1, and if we need to calculate the Q3, then we just simply multiply this one by 3. And the L, CF and F, I have told you while telling you the formula of median. And now since the time limit is very tight, I will not explain about the example of mean deviation, but I'll surely break down the formula for you all. You can check the example in book, it's already given there. So for mean deviation, individual series, MD from mean is summation x minus x bar by n. From median, it is summation x minus md by n. And from mode, of course, it is summation x minus mo by n. So this one is for individual series, and for the discrete and continuous, we have from mean it is the same, that is summation x minus x bar by n, same as the individual. And median, we just need to like multiply the frequency, multiply it with the frequency, and this is the formula for median. And from mode, it is obviously the same as median, we just need to replace it with the mode. And talking about its coefficient can be calculated by just the mean deviation that we get from mean divided by mean, and the mean deviation that we get from median divided by median, same as the mode, mean deviation that we get from mode divided from mode. So like that, my part ends here, and I would like to hand over to Ansu.
Thank you, Jessica. Now I'm going to be talking about standard deviation and variance. Standard deviation is the measure of how much a number differs from its mean or average in a group. I'm going to be discussing about the computational method. This is by definition. Direct method. Here D equals to x minus a, where a is the assumed mean, and the final method is state radiation method. This is for individual series, and now for discrete series we have Due to time limit, now it's for
Thank you. So now I would like to talk about coefficient of standard deviation, coefficient of variation, and likewise skewness. So I will write the formula of coefficient of standard deviation. That is standard deviation upon mean. Next is coefficient of variation. This is defined as the product of coefficient of standard deviation and into 100. That is given as mean into 100. So when we compare two variety of two series, suppose A and B, we generally compare the coefficient of variation, that is CV. So if A has more CV, then it is likely to be less stable and less consistent. And if the coefficient of variation is less, then this is considered to be more stable and more consistent. So now next is combined mean deviation. It is given as mean 1 2 equals to under root n1 sigma 1 whole square and 1 sigma whole square and 2. So this is the formula for combined mean deviation, where d1 is equals to mean 1 minus mean 1 2. d2 likewise is equal to mean 2 minus mean 1 2. So here this is given as n1 mean 1 plus n2 mean 2 and 1 plus n2. So this is for the combined mean deviation. Now I would like to move on to mean square deviation. So mean square deviation is defined as the square of standard deviation, that is summation f x minus a whole square upon n, where a is the arbitrary number. Likewise, it has positive root square of mean square deviation, so its formula is given as under root summation a square upon n. So these are the mean square deviation and the positive root of square deviation. Now I would like to move to skewness. So the frequency curve that is drawn by taking varied values along x-axis and the frequency along y-axis, they are not symmetrical. Hence, the mean, mode, and median do not coincide. So this measure of asymmetry is known as a measure of skewness. So there are three types of skewness generally. One is symmetrical, another is positively skewed and negatively skewed. So let me draw the graph and explain. This is known as symmetrical skewness, that is here mean, median, and mode, everything is equal. So a frequency distribution where the curve has longer tail on the right side is considered as positive skewness. So here the condition is shown as mean is greater than median greater than mode. So likewise for negative skewness, the tail has to be drawn longer to the left side. Here the mean will be less than median, less than mode. So this is for the skewness. Now moving on to the formula, we have first measure of skewness. The formula is given as sk is equals to mean minus mode. So we have another formula where the mean, where the mode is ill-defined or bimodal case. So in this case, if the mode is difficult to find out, then we have another alternative formula, that is free mean minus median. So this is for the first measure of skewness. So now from our exam point of view, the most important is Carl-Pearson's method. This is for finding out the coefficient of skewness by using Carl-Pearson's method. So we have by standard deviation. So here also we have alternative formula. If the mode is ill-defined or if we have bimodal case, then we can use the formula 3 median upon standard deviation. So this is for the Karl-Pearson's method. This is known as Pearsonian's first measure, and this is known as Pearsonian's second measure. So by using this formula, the obtained value we will get from -1 to +1. So while doing the exercise, the value should not exceed from here. Now next is Wallace coefficient. So here we use the quartile deviation, that is skewness, measure skewness is given as Q3 plus Q1 minus 2 MD upon Q3 minus Q1. So this is for Wallace coefficient. Now, last but not least, we need to find out which method should be used. So if we have open end class, then we should use quartile deviation. If we have more complicated data, then we should avoid using standard deviation. So this much for today. Make sure to like, share, comment, and subscribe to Space Arts channel.